Hello, my name is Ken Francisco. I'm a parent and electric line supervisor for New York State Electric and Gas Corporation. I've worked with and around high voltage electricity for many years. It has been my experience that most electrical injuries can be foreseen and avoided if only people would take a few moments to step back and think about what they wish to accomplish. As an emergency services provider within our service area, we are particularly interested in keeping you and the families you serve safe. We both share the common goal of providing the public a safe living environment. To that end, we have produced this video and a companion procedures guide. We hope that you will step back, think about the dangers posed by high voltage electricity. Please share your knowledge with your co-workers, families, and people in the community. Pay careful attention to the information presented. You may save your victim's life, your life, or the life of someone you love.
Every day in the United States, first responders are called upon to handle emergencies involving electricity. Your practices, procedures, and actions can keep you from becoming the next victim. A best practice is to maintain a hands-off and keep your distance policy until our trained employees have dealt with all electrical hazards. When it comes to electricity, the partnership between the utility and the first responder may be the difference between a successful rescue and an unfortunate tragedy. Even for electrical workers, there is always a danger. In this instance, because our worker was properly attired, he suffered no injuries. Someone less prepared would not have been so lucky. Electricity is powerful, unforgiving, and predictable. Analysis of accidental contacts with electrical sources show that most could have been avoided. Other than the very few intentional contacts, most electrocutions occur because of carelessness, a momentary lapse of concentration, or simply not understanding the nature of electricity. Then there are those people who feel lucky. So lucky they think they can cheat death or severe injury. But the reality is that electricity is subject to the laws of physics. The simple truth is that electricity can and will kill if circumstances allow. There is no breaking of the laws of physics. Our aim is to provide you with the knowledge to keep you safe. Your utility company regularly conducts live line demonstrations to help teach the power and predictable nature of high voltage electricity. Your utility company has many programs used to teach our children at a very early age how to behave around electricity. Your utility company also conducts live line demos for people like you, first responders, for the very same reason. When it comes to safety, the aim is to give you the information necessary for you to work safely around high voltage electricity. In this video, you will see excerpts from several different live line demonstrations. Regardless of the audience, every live line demo's main emphasis is safety. Safety for both the demonstrators and the audience. You can never be too careful around electricity. Sometimes when your power is cut off, it's due to weather. Sometimes an automobile accident brings down power lines. Sometimes animals get between an energized conductor and a ground wire and a fuse blows. At our live line demonstrations, wooden squirrels on the ends of our insulated sticks do it. And tragically, there are times when something else happens. It's all about conductivity, about how electricity always seeks a path to ground. It doesn't matter where the path leads, even if it's through you. Electricity may also travel through something you might think it couldn't possibly move through, like a tree limb. Before you climb or lean any ladder against a tree, stop and look up. Search for wires and never climb into any tree that has grown into the power lines. The fabled kitten up a tree story could have a tragic ending if you are not careful. Even kiln-dried wood can conduct electricity with undetectable amounts of moisture present. Wood may have been exposed to conductive contaminants or impregnated with conductive preservatives. That means you should never think you can get away with moving a downed wire with a piece of wood. For that matter, with anything else. Our people have been trained and have the right insulated tools to move wires. What about the specially designed fiberglass insulated sticks our line workers use? They are designed to withstand very high voltages, up to 100,000 volts per foot for 5 minutes when used properly. You should never move a downed wire with this tool without proper training. And unless this tool is properly maintained and cleaned, it can be as lethal as any other conductive material in contact with our wires. We maintain and clean our insulated tools on a strictly enforced maintenance schedule. Unless you are trained, unless you have the experience, and unless your live line tools are maintained, don't move any wires. Let's take a look at one of New York State Electric and Gas Corporation's public service TV messages. One that makes no bones about electricity always looking for that path to ground.
Come on, hurry up! The wire!
Should you come upon a scene like the one just described, restrain that urge to immediately offer aid. Contact your local utility. It may just keep you from becoming a victim. Remember that the path to ground could be through anything that comes into contact with an energized line, your emergency vehicle, an extension ladder, your hose, or even you. In fact, the object doesn't have to be very high, just high enough to provide contact with electrical wires and a path to ground. You must never forget, without the proper gear or clothing, you are highly conductive. At your local utility, their employees are constantly schooled on the safe handling of electricity. And because they care about their employees, they insist that every time the line mechanics work with electricity, that they wear special protective gear. They also insist that before they use this protective gear, that they must test it. Here, high-voltage rubber gloves are being air-tested looking for pinholes. Pinholes? More about that later. Like a physician preparing for surgery, eye protection, special dielectric hard hats, flame-resistant shirts, insulated sleeves, insulated gloves, gloves designed to withstand up to 20,000 volts, and of course, insulated sticks. But most of all, they have provided them with a great deal of knowledge. These are the required tools so necessary to keep workers safe. Unless you are a fully qualified, fully outfitted, and experienced utility worker with the appropriate protective equipment, you are putting yourself and the victim in jeopardy. Even at our live line demonstrations, many precautions are taken to be absolutely certain that the current is on only when it needs to be. The laws of physics regarding electricity never change. It's a fact that water conducts electricity because it contains dissolved minerals. Here, for example, electricity is flowing through the water in this plastic pipe, completing the electric circuit and lighting this light. This means you should never use an electrical appliance, tool, or rescue device not specifically manufactured for wet environment use. You need not be in an area of heavy moisture. Life-threatening situations can arise from even low levels of moisture and electricity. Moisture? Just watch. Rope. It might be the kind you have on your rig, in your garage or shed. It contains moisture, but so very little that it feels dry to the touch. There might be some dirt or grease on it. You wouldn't think it was conductive, yet it conducts enough current to light this bulb. If you were touching this rope, you might glow too. We are often asked about the conductivity of standard issue canvas and rubber hoses. This pretty much answers that question. Our best advice is to do everything you can to keep your lines from coming in contact with ours. Never park your pumper trucks under our wires if there is any chance that they may come down. If the wires come down, the path to ground will be through the truck, down the hose, and assuming you're the firefighter holding the nozzle, well, you don't want to be holding the nozzle. Another way to protect yourself is to stay out of substations. If there is something in there that you have been asked to retrieve, or if there is a victim inside of the substation, contact your utility company before attempting entry. It could save your life and that of the victims. Unfortunately, kids sometimes fly their kites into our lines, and you may be called to the rescue. Be careful. Often the string will burn and will not be there when you arrive, but not always. This is a commercially sold string for use in electric fences. It is sometimes used by kids for kite flying because it is made stronger with metallic threads. It is very dangerous and should never be used where electrical contact is possible, such as kite flying. If this type of string comes in contact with our wires and causes someone to be shocked, exercise caution as you approach the victim. The kite string may still be intact and still pose a considerable shock hazard. If you see the string still in contact with our wires, notify your local utility before approaching. People often wonder why we are so concerned about electrocution from kites contacting our wires. After all, the wires are covered with insulation, right? Wrong. The black plastic covering on our wires is strictly protection for the wires. It is not insulation. Hundreds of people are seriously injured each year. Many are would-be rescuers, thinking that the black covering will protect them from shock. It doesn't. Don't be fooled into thinking about electrical wires in the same way you think about water pipes. You cannot judge a wire's voltage or current carrying capacity by its size. Here we can see varying thicknesses of wire, each capable of carrying currents which could seriously injure or kill the largest and strongest person you know. As an example, these 3 wires are rated to carry 15,000 volts. These wires are all rated to carry 5,000 volts. And these may carry up to 600 volts. Always remember, regardless of their size, any of our wires can conduct enough electricity to kill you. What about birds? You see them sitting on the wires all the time without any problem. Birds don't get shocked because they aren't touching the wire and the ground, or any object in contact with the ground. They fly and land on the wire without ever touching the pole. It is unlikely that you could touch a wire without being in contact with a grounded object. Remember, utility poles, a ladder truck with its outriggers extended, even fire hoses are grounded objects and will provide the electricity a path through you and then to ground. Here is something you don't want, protection that doesn't work. This air test determines that this ordinary, high-quality rubber kitchen glove has no pinholes. So far, so good. But watch this. If you are performing a rescue and think that household rubber gloves, your damp service or work gloves, get you home free, think again. Never use anything other than specially manufactured high-voltage gloves and protectors, properly maintained and tested, around high voltages. All first responders now carry latex gloves for protection against diseases from blood and body fluids. You should keep this in mind. While your latex barrier gloves provide excellent biohazard protection, they never should be considered for use around electricity. We've previously talked about pinholes and air testing. Why? Because electricity is predictable, and it will search for any path to ground. Here is a professional line worker glove, designed to withstand 20,000 volts. But this particular glove has a tiny pinhole in one finger. Watch. Now using the same glove, let's add a highly conductive and readily available substance. Plain tap water. Now you know why our line workers are so attentive to the condition of their equipment. Wouldn't you be? We laboratory test our gloves monthly and destroy any that fail the electrical resistance test. So even if you have a pair of line workers' gloves, it is unlikely that you have had them lab tested recently. And now you know why we keep saying, when it comes to electricity, there is no such thing as being too careful. Another of New York State Electric and Gas Corporation's public service television spots warns against the dangers of working where you might contact or perhaps even cut through an energized line. Never pull a meter or cut a service wire to interrupt the flow of electricity. There may be a load on the meter and it may explode if you pull it out of its base. As for cutting into a wire, ever wonder what might happen if you did? We know. Here we're working with 240 volts. The power in this line is no greater than that found in the service cable to the average home. Remember, if you are on a roof, you can easily come in contact with a service cable without the special protective gear our line worker has on. How do you think he would fare in this situation? How about a fireman or a trooper? How do you think any of you would fare if this wire were 7,200 volts instead of only 240? Not much left to the imagination. It is often said that seeing is believing, and yet you might see what appears to be a harmless wire, a wire very much like this one, lying in a yard or in the road, and you see nothing that would scare you. Nothing but a wire. It's not arcing, it doesn't look dangerous. Well, open your eyes. Seeing is believing. And while we are on the subject of seeing, get in the habit of holding your hands like this if you have to maneuver through an area of poor visibility where you might contact power lines. If you make contact, the contraction of your muscles will throw you away from the wire. If your hands are like this, you might clamp onto a live wire and be unable to release your grip. Though you can't always see electricity, you must always assume that it's there. It's powerful stuff. These rocks that look like lava are pieces of the earth, plain old dirt, dug up from where a broken line allowed electricity to arc to ground. And speaking of arcs to ground, wait till you see this. You may think I'm safe with my standard issue rubber and canvas boots. Really? Willing to bet your life on it? Because that's what you are doing. All it takes to complete the circuit to ground is your body, made mostly of water, and a rubber boot that is a little dirty, maybe some soot from smoke, a little moisture. Perhaps you have a pair where one boot has a pinhole in it, or is made with conductive compounds, as many are. Boots are made to keep your feet dry, and not to protect you from electricity. Now let's take a look at long-distance electrocution. The major culprits in this danger are auto accidents and storms. This is a serious danger to the public and to the rescuer. Keep your rigs away from guardrails and metal fences. It's as simple as that. Imagine that this fence goes around a large field. It could be any fence, maybe the chain link fence around your neighborhood schoolyard, or a guardrail along the county highway. Continue to imagine that off in the distance, beyond your vision, a power line is down and lying across the fence. You get the idea. Don't forget what you have just seen, especially if you are out on a call after a storm or responding to a motor vehicle accident. And remember to stay in your vehicle and remind the passengers to stay in their vehicle until the power is cut off. Here's an all too common situation, especially in your line of work. There's one simple rule to remember about a car with downed electrical lines across it. It's hot. It's energized. If you touch it, you could die. During this presentation, you will be given handouts which review the correct procedures for wires on a vehicle. Do not approach the vehicle. You may be electrocuted even if you don't touch the vehicle due to step potential, caused by bridging two areas of differing electrical potential. The most important rule to relay to the occupant is to stay put and not to leave the vehicle. Let them know that they are safe as long as they don't step out. Explain that your utility has been called and they will be removed as soon as the power is shut off. During the wait, make sure other would-be rescuers don't become the real victims by approaching too close to the vehicle. If and only if the victims must get out, for example, if their car is burning, tell them to stay put until you have explained everything they must do. 1. Instruct them to leap free without any part of their body or clothing touching the energized vehicle and the ground at the same time. Why? Because if they are in contact with the ground and the energized vehicle, they will be the path that electricity will flow through on its way to ground. This is very important. 2. They must not run or even walk away once they have jumped clear of the vehicle. Have them try to control the urge to run or even walk once they have cleared the vehicle. Why? If they walk, their feet will bridge two areas of different electrical potential, and they can be seriously hurt or killed. So what should they do? 3. Using small shuffling steps, keeping both feet on the ground. Move slowly away until they are at least 50 feet away from the wires. Why? Because we don't know the voltage of the electricity leaking from the downed wire, and we want them and you to be safe. As our line professionals in their personal protective gear begin to wrap up this demonstration, we want to re-emphasize the word professional. To us it means trained, knowledgeable people, and it means using the right equipment. To you, it's important to understand that having one without the other is simply not enough. For example, these days everybody seems to have a hard hat. Now, our hard hats are rated to withstand up to 20,000 volts, and yet without the knowledge to use them correctly, the electrical insulation that they provide can be defeated. As an example, let's see what would happen if someone wearing a wintertime hard hat liner had been perspiring just a little. Without thinking, they tied their damp ear flaps on top of their hard hat, then contacted an energized line. That gets the message across, doesn't it? The same could happen with most head coverings used by first responders. What happens in an electrical contact? This hot dog has about the same consistency, the same moisture content as the human body. Your body, let's say. Need we say more? In the last few minutes, we've covered a lot of ground. So let's quickly review the important points. When you come upon an accident scene, don't approach any electric wires, whether on a pole or on the ground. Assume all wires are dangerous, regardless of their diameter. Never climb a utility pole or tower unless you have been specifically trained as a line worker and have the correct gear. Never pull a meter to interrupt the flow of electricity. Unless properly trained, never cut a service supply cable. Never touch a wire, even if it appears to be insulated. Remember, the plastic is protection for the wire, not insulation. Never go into a substation. Contact your local utility. Stay out of trees that have power lines running through them. Wood is an excellent conductor. Teach kids to never fly kites near power lines. Do not use electric appliances near water unless they were designed for use in wet environments. If power lines are touching a car, 1. Have the victim stay inside. 2. Keep other people away. 3. Reassure the victim. And 4. Contact your local utility. If a car with a wire on it is on fire and the victim must leave the vehicle, remember, 1. Have them jump clear of the car without touching the vehicle. 2. They should not walk or run. 3. Have them use shuffling steps to move at least 50 feet away from the vehicle. Yes, when it comes to electricity, there is no such thing as being too careful.